Time travel. Few ideas have captured the human imagination as powerfully or persistently. Long before the term existed, ancient civilizations spoke of individuals who slipped forward or backward in time, mystics, prophets, and mythical beings who experienced the future before it arrived or revisited the past long forgotten. In ancient Hindu epics, time flowed differently for the gods. In Norse mythology, time loops through fate and prophecy. Even the Bible hints at temporal manipulation, suggesting our fascination with time is as old as storytelling itself. Fast forward to the 19th century, when H.G. Wells gave time travel its first real scientific framing. The Time Machine didn't just spark a genre, it rewired the way we think about time. No longer was it just a river we floated down, it was a landscape we might traverse. In the decades that followed, the idea exploded. From the whimsical paradoxes of Back to the Future, to the dystopian loops of Looper, and the mind-bending spirals of Interstellar, time travel evolved into a cultural phenomenon. Not just in films, but in books, TV shows, video games. Each iteration posed the same question in different ways. What if we could change the past, or glimpse the future? But step outside the pages of fiction and into the realm of physics, and the rules change dramatically. According to Einstein's theory of relativity, time is not a constant. It stretches, warps, and flows differently depending on speed and gravity. A clock on a speeding spaceship ticks slower than one on Earth. Near a massive black hole, time dilates so dramatically that minutes for one person might equate to years for another. This is not science fiction, it's measurable, proven physics. Then there are wormholes, hypothetical tunnels through space-time, potentially linking distant points in both space and time. If such structures could exist and be stabilized, they might allow travel between different temporal coordinates. But there's a catch. Or several. The energy required would be astronomical, possibly exceeding the total output of entire stars. And even if that energy problem were solved, there's no guarantee a wormhole wouldn't collapse the moment someone entered it. And then, there's the real kicker, the paradoxes. The most famous of all is the grandfather paradox. Imagine traveling back in time and preventing your grandfather from meeting your grandmother. If they never met, you'd never be born. And if you were never born, who went back in time to interfere? This logical loop isn't just a storytelling dilemma, it's a serious philosophical and scientific problem. It forces us to confront deep questions. Is the past fixed? Do we have free will? Is the universe deterministic? Some theories try to dodge the paradox. Quantum physics suggests parallel universes might split off from every decision or intervention. In that model, killing your grandfather doesn't erase your existence. It just shunts you into a new timeline where you never existed. Meanwhile, the original timeline continues unaffected. It's elegant. But it's also completely unproven. And yet, despite the paradoxes, despite the energy requirements, despite all the unanswered questions, scientists are still looking. Because time, it turns out, is stranger than we ever imagined. Quantum entanglement shows us that particles separated by vast distances can appear to influence each other instantaneously, challenging our basic assumptions about cause and effect. Recent experiments suggest that our understanding of time might only scratch the surface of a far deeper truth. Some physicists even believe time might be an emergent property, not a fundamental aspect of reality, but something that arises from more basic processes we haven't yet fully grasped. So, where does that leave us? At the edge of possibility. We may not be building time machines anytime soon, but the pursuit is real. The science is advancing. And the implications are massive, not just for physics, but for ethics, identity, and the way we define reality itself. If you're enjoying this deep dive into the mysteries of time, take a second to like this video and subscribe to the channel. It helps us bring more thought-provoking stories like this one to curious minds like yours. Time travel, whether real or not, is more than just a scientific puzzle. It's a mirror reflecting our deepest desires. To undo regrets, to understand origins, to peek ahead and see if we'll be okay. It reminds us of our vulnerability to time's passage, and our defiance of it. And perhaps most intriguingly, it forces us to question what time really is. Is it a one-way street? A landscape? A loop? Or something even stranger? The truth is, time travel may never be simple. But the questions it raises are too important to ignore. So what do you think? Will we ever crack the code of time? Or is it destined to remain one of humanity's most captivating mysteries? Share your thoughts in the comments, and keep exploring.